we're going to use this process of bringing this point closer and closer to actually calculate a slope. Okay, so it's going to look like this. We've already set up the kind of situation here where we have our rise and our run. And as we bring this point closer, our change in y over change in x becomes 0 over 0. So that's a problem. So we're going to get around this by using a limit. So when we set this up, it's going to look like this. So my rise, so this portion here represents the rise. So we're going to find the slope of this parabola right at 2. Okay, and that was actually the picture back here. This slope, this is at x equals 1. So we're going to find the slope of this parabola, same parabola but a different point. We're going to find it at x equals 2. So there's our rise. Okay, so this represents our run right here. And so to find the rise, I find the difference between these 2 points. So that coordinate is defined 2, 4. And we're just going to move a little bit over, say plus h, and this new y coordinate is 2 plus h all squared. So I just plug it into that function. So the expression for my rise is going to be like this, 2 plus h squared minus 4. And the difference between these 2 points is going to be h. So it's going to be 2 plus h minus 2. So we're just going to have a width of h. So it looks like this. We're going to have 2 plus h squared. So this is my slope ratio here. And we're just going to let the h go to 0. So 2, there's my rise. Okay, and then my run is going to be, I'm just going to simplify that to h. And I'm going to do a limit on this. So I want to find out when this is equal to 0. So when I make it equal to 0, I'm going to get 4 minus 4 over, which is 0 over 0. Okay, so I can't do that. I have to be able to algebraically rearrange this, and hopefully I can work that out. So this is what I'm going to do. I'm going to see if I can get rid of that divide by 0, and see if I can figure out what that slope is supposed to be. So limit as h goes to 0, this is going to be 4 plus 4h plus h squared minus 4 all over h. Okay, so there's my limit. These 4's cancel out, and notice that, what conveniently happens is I have this divide by h factor cancels out with those h's there. So I'm left with the limit as h goes to 0 of 4 plus h. There's no divide by h anymore, and I can now evaluate my limit. My slope is 4. So when I look at this graph, as the graph approaches 2, the slope of the tangent line is going to be 4. Okay, so this is not actually a good scale. So this one over here, this graph here, is actually a little bit better scale. And if you take a look at that point right there, that's the point we're actually finding the limit for. If I actually draw a tangent line to that, okay, well, it is fairly arguable that we can make this tangent line, and maybe I'll just draw it a little bit more accurately. That tangent line slope actually has a rise of 4, run of 1. Okay, if I draw this on Desmos, it will be much more convincing, but there it is. We're finding the tangent line at that particular point. And although we get 0 over 0, because we can use a limiting process, we can use this limit of 0 over 0, we get the actual numerical value of 4, which looks perfectly good. So we can do the same thing here. We can find the limit for this slope here. Okay, so if I just sketch a quick graph of this, it's going to be some parabola. I have some point at x equals 1 right there. Okay, and I want to find this tangent slope right at that point. Okay, so I'm finding the tangent slope there, and I'm going to do that by using a secant line. So I'm going to just draw my secant line on this side, and I'm going to let that green point get closer and closer to the blue point, which then limits it as our point. Okay, so setting up my limit then. I'm going to find the limit as my h goes to 0, as those 2 points get closer together. My change in y is going to look like this. X plus h squared plus 2. So I'm going to plug in my x plus h into there. minus, sorry, my mistake here. It's going to be 1 plus h squared, because I'm at x equals 1. Okay, so this point here is going to be 1. In this case, it's 1 minus h, but we'll just leave it as plus h. That height of that point is going to be 1 plus h squared plus 2. So I'm going to have my plus 2 in here. Minus the point when I put x in here. So y is going to be 3 at that coordinate. Okay, so that point is going to be 1, 3. There's my rise, the difference between the 3 and that point. And then the run is going to be the h, okay, the distance between those 2 points. I'm going to try to get rid of that divide by 0. So I end up with 1 plus 2h plus h squared plus 2 minus 3. Okay, so those cancel out. Okay, so I get plus 1 plus 2 minus 3. I'm left with these h factors, which now these h factors can cancel out. I've gotten rid of my divide by 0, and I can now evaluate this limit. So limit as h goes to 0, I'm left with 2 plus h. Well, that is equal to 2. So that means the slope at that point is equal to 2. Okay? And if I look back at my parabola, this parabola back here, if you recall, the point at that point on the curve, yeah, it looks like definitely like a slope of 2 at that point. Okay, but now we've used a limiting process. We've kind of shown algebraically that in fact it is 2. So we can try this for this point as well.